And those partial charges will attract to neighbor molecules. If it's nonpolar, you don't have charges. You don't even have partial charges. All you've got that holds nonpolar things together, it's called temporary partial charges. But let's just think of this as friction. The term is London dispersion forces. Dispersion as in disperse, scatter. If this atom with its valence electrons collides with another atom and its valence electrons, then in isolation these guys only saw each other, correct? But as soon as these come together, all of a sudden they feel electrons on the other atom, and those electrons will scatter away from the point of impact. Basically, friction sends the electrons flying. And that gives you these flashes of what's called temporary partial charge. There for a moment and gone. Very, very weak, but it's all you got. And that's why they're very weak forces. Nonpolar covalent is the other extreme. That's your weakest force. And it's because you don't even have real true partial charges. You just have temporary ones that come up in a flash as a result of friction. Now with polar, you do have partial charges. And we just need to look a little bit closer in terms of what's called dipole attraction or hydrogen bonding. Because they're structurally the same, but the difference is strength. Hydrogen bonding works exactly the same way as dipole attraction. It's just that you have H, F, H, O, or H, N bonds. These particular linkages are extremely polar and therefore give you bigger partial charges. So we're looking at ionic, extremely polar, dipole attraction meaning polar, and London meaning nonpolar. From bottom up, it's temporary partial charges, very strong partial charges, and then complete charges. All of this is a charge-based behavior. All the attraction between one molecule and the next is charge-based. And the more developed those charges, the more strength there is. So let's compare these four. In terms of who's got stronger forces than who. highest boiling point, lowest boiling point. And we want to rank them in order. First thing to do is go through and categorize them as ionic or covalent compounds. Magnesium chloride, ionic or covalent? Ionic. Phosphorus trichloride. Carbon dioxide. Ammonia. Hydrogen still a nonmetal. You're thinking ammonium as an ion. This is not charged ammonium. This is neutral ammonia. That's covalent. So just by doing that, we've already found the one with the highest boiling point, because ionics trump all others. That's the order of progression. So this one inherently has the strongest forces. We're ranking them by highest boiling point, but that would also mean highest surface tension, highest viscosity, highest melting point, lowest vapor pressure, least volatile, and so forth, because all those properties go hand in hand. Because inherently, that's the one with the strongest forces. Now, these others are all covalent, so then we go to criteria 2, and that's figuring out whether they're polar or nonpolar. We've had these Lewis structures up here. I think, well, close. I know we had this one. We had NCl3 instead of PCl3. Just to save time, I'm going to go ahead and draw them all up. This is their Lewis structures. And we want to categorize them based on polar or nonpolar. Make sure you get all your dots in there where they're supposed to be. CO2, polar or nonpolar? Nonpolar. PCl3 and ammonia. So what have we figured out by looking at polarity? CO2 is going to be on the low end here, right? Because that's our only non-polar one out of this set. That's the one with the weakest forces. And that leaves us with 2 that are polar. And so this is where we go into, is it an ordinary kind of polar or is it an especially powerful kind of polar? And that's where you start looking for HF, HO, HN linkages in the molecule. This one has those, so it's extremely polar. This one does not, so it's just an ordinary polar. So ammonia would be that hydrogen bonding, extremely polar, whereas the PCl3 would be just an ordinary kind of polar. This is London dispersion, this is dipole, this is hydrogen bonding, and that's ionic. Do you see how to do that out of Lewis structures? Take a look at these 2 structures. Is either one ionic? No. Is either one nonpolar? No. They're both polar. Is either one capable of hydrogen bonding? Which one? The bottom one. Now remember, and I guess I shouldn't have erased this, but we're specifically looking for these kinds of bonds. And so where the top one has hydrogen and oxygen, nowhere does it have hydrogen bonded to oxygen, right? And so even though it's got the same elements as the one below it, it doesn't have as much polarity as the one below it. H to O is extremely polar, and by extremely I mean just this close to being ionic. And that makes it especially powerful, and that makes it especially cohesive. This is an ordinary kind of polar, so that's dipole attraction. This is extremely polar because of this part right here. That's what's called hydrogen bonding forces. Of those two structures, which one has the higher surface tension? The second one. Which one has the higher vapor pressure? The top one. Which one has the higher viscosity? Bottom one. Which one has, did I do vapor pressure? Yeah. I didn't do vapor pressure. All right, well anyhow, you see the patterns, right? You need to know what behaviors go along with strong attraction, and you need to be able to go from a Lewis structure to figure out who's got what kinds of attractions. Who's got ionic, who's got dispersion, who's got dipole, who's got hydrogen bonding. And that will allow you to make these kinds of comparisons. All right? Question? You got something? Okay, last thing. Matt's got something to say here, but before we do that, today being Wednesday, Monday is fall break. Yay for fall break. Wednesday, unfortunately, is exam 3. Boo, exam 3. I know how you feel. Don't smile. I know you're not liking it. But it's the way it has to be. It's just the way it has to be. So while you're on break, take a look at this stuff. Preferably now, before Friday, while it's fresh. Take a good long look at this stuff. And if you did not copy this down, or if you came in late, this is the summary of what's for the test. This is what you focus on. Go ahead.
Okay, so he just making sure that we're making feel really good. So you will have a study session Monday. So the people who were here earlier from the SI session, we kind of came in on just a general time that worked for everyone on Monday. So I will be here Monday in this room. So Monday, AL 223, it's this room, from 12 to 2. So you'll have a 2-hour study session Monday. So that will make up for your study session that you would miss on Monday because of fall break, and that will give you an extra one for the test. So you should all come, all the ones that aren't going on the biking trip.
Biking trip, yes. Anybody that's interested in going on the biking trip, I need to know soon.
I'm interested,
But
just study.
aw, come on.
So that is
Not
so.
the only test. You want to cancel the test?
I'll help you review the whole way up and the whole way back.